one-sided, two-sided limits, you want to be on the lookout for that plus and the minus. So think of plus as you're coming from the pluses, the right side. So you're coming from all the positives, and then the little negative guy means you're coming from the left, from all the negative guys. Squeeze theorem, that's like where your middle function is kind of like, I don't know what that's doing over there. You're like not positive what it is. So what you do is you pick like functions that you know are always below it and always above it. And if each of them equal the same limit, it forces the middle one too. So that's easier when you can see a picture. So I'll show you an example with that. So I don't know if you did this already, but like every single limit, the first thing you should do is plug in the number, because then it's like way easier and you're not like trying to freak out with algebra or like get your calculator out to look at the graph. So like that one looks terrifying, but just plug in 2 and maybe it'll be nice. And that's what you do. The second you plug in 2, okay, you drop the limit. Okay, so it is bad notation if you have the limit carried down, which is, believe it or not. Okay, so make sure that you don't have the limit sign. You can put like a little death if you did, because then you can like, oops, I wrote an X there. And then now it's just kind of like brute strength in solving that. So I'm just kind of cheating from what my notes is. You guys know how to plug stuff in. So 10/9. You actually get like a nice number. It's not an indeterminate form. Okay, so that's what's nice. Okay, for number 2, again, I'm trying to do like the hardest ones here. So because you guys have done the class already, you could do L'Hopital on here, but I'll show you how to do it with like not L'Hopital, so I'll show you both of them. So say you didn't remember anything about L'Hopital, which could happen. I mean, sorry about that. But if you plug 0 in, you get 0 over 0, which is an indeterminate form. Okay, so that means you got to mess with it. So like other ones, you could like factor and do conjugates and all that junk. Whereas this one, like tangent, remember with L'Hopital, actually, no, I'm not going to do that. I'm going to show you the algebra way. So you're going to have to mess with it. So factoring, conjugates, tangent. I mean, the only really thing you can do is change it over sine over cosine. And then you just got to kind of, like I said, mess with it. So it's like you can actually take the limit of it. So you could do like sine x over cosine x times 1 over x. And then you're like, it's still 0 times 1 over 0, which is indeterminate still. But this was the key, is switch around the x and the cosine. That's the key. Okay, so if you do that, okay, when it's like that part, this is one of the limit rules where you can do them both separately. So you can do this where you can go sine x over x times limit of 1 over cosine x. Okay, that's one of the rules. But then you have to remember this is a very popular limit. Okay, so that one, the sine x over x, is like very famous. Okay, so that one is 1. Okay, and that just comes out of your brain. You could do another L'Hopital on it though. If you really needed to, you could do another L'Hopital and kind of grit your way through it. And then you get times, that one is 1, so the answer is full on 1. Okay. If you did L'Hopital, that's like the one that's really annoying with all the work. Do you remember doing all that where you have to say like, the limit as x approaches 0 of tangent x equals 0. And then you got to do the denominator separate. So this is technically like not learned yet. Do you know what I'm saying? But if you did this on a test, that's fine because you guys already know it. So you could do L'Hopital. You run the risk of having to know your derivatives of all the stuff. But if you remember it, good job. And then you write it in cursive. You don't have to. I just think it looks fancy. So by L'Hopital's. Woo. Fancy, fancy. Oh, wait. We forgot the therefore. Remember? Isn't it satisfying? No? Okay. So if you did by L'Hopital's this limit of tangent x over x equals, and then what you can do is take the derivative of the numerator and denominator. So this is what I'm saying. Like, you have to remember derivative tangent. Does anyone know? Do you remember it? Yay! You guys know things. Good job. Secant squared. And then this is 1. And then what you're doing here, you can think of it. This is another rule that you can do with limits. Is like you could just do secant and then square it like at the end. But then you might be like, man, I don't know what secant is. So again, there's pros and cons to all of these. So it kind of depends on your brain on what you want to do. So like 0 is going to end up here. If you do this like goofball triangle, right, this would be 1, 0, 1. So then secant would be hypotenuse over adjacent, which is 1. Oh my gosh, it's the same. Oh, okay. So it kind of depends. If you're doing this on F or Q, you got to do this whole shebang, but we technically haven't learned it yet, so just be careful with it to like make sure you're doing all this. And then this guy is just brute strength. Okay? Any questions at all? No? Okay. All right, so this guy is like if you're given a table and a graph. Okay, so this one, oops, I didn't want to highlight that. We have the x approaches 2. So what you need to be doing is looking at here on the table, or you could do this guy. So because the limit from each side doesn't exist, the left and the right don't match, this is going to be does not exist. Okay, so does not exist. I put this one on here because a lot of you are probably pretty good at this one, but people will do, wait, I need my dried blood pen. There we go. Death. People will write the limit as x approaches 2 dne. That's really bad because the way that looks is like, that's what it looks like. Do you know what I'm saying? Like there's not, like you're always taking the limit of something. So it's like, it would be like saying a square root equals does not exist. You know what I mean? With nothing in it. So this is just a really bad notation thing. And I see when people go fast through tests, they do all that dumb stuff, which that's not you, right? Okay. Again, a lot of these are notational things. So like number 4 is a piecewise. So what people tend to do with this one is they actually write the equation in the limit, which is wrong. Okay, so f of x represents that total thing there, like all the equations, everything. So when you're doing left and right limits, yes, you're focusing on one versus the other, but if they're asking you, what about of f of x? Okay, you need to make sure you're matching that notation. So like if you're doing the limit as x approaches -1 from the right, you need to write f of x. Okay, you cannot write that -x squared 1 at all. That's really bad notation. Okay, so, oh, it made it as a favorite. Yes. Okay, good. So again, death. It's like really dark blood, but that's okay. So like if you wrote the, like this thing, -x squared minus 4x minus 4, that's wrong. Because now you've like changed what f of x is. You're changing like what you're solving for. Okay, so you write it as the f of x piece, and then you're going to plug it in. Now you can like show that you're plugging it in because you're dropping the limit. You know, so you're going to plug in the -1 minus 4 times -1 minus 4, and then kind of get a little anxious with all the negative signs, but you then evaluate it. So again, oh, I didn't go here. So this is from the right. So that's why I'm using this one, because that's where x's are greater than -1. So I'm coming from the right side of it. And then alg action, I think that was -1. Is that right? Yeah, because the 4's cancel. Yeah. So that ends up being -1. And then for the other one, you're going to do the same thing. But again, just really, really watch your notation. You need to put something with the limit, but it can't be like the legit equation. Okay. So make sure you write actually f of x. And then you can be like plugging in -1 minus 8. -7. So if they just ask you what's the value of the two limits, this was actually an FRQ once. And people said they then like did all this extra stuff saying like the limit doesn't exist and blah, blah, blah. Nope. All it is do them left and, do them separate and that's it. Okay. Any questions with that? Okay. 5 is like absolute value because you can't really like, it's like you kind of want to cancel them, but you're like, well, is that illegal? I don't know, So the way you approach this one, obviously, is with this guy going on, okay? You can kind of rationalize through what kind of values are being plugged in. What happened to it? Plugged into X. That was really weird. I don't know what I hit. Okay, so anyway, so when you're plugging stuff in for here, as x approaches 0 from the left, think about what your x's look like. So what is this, if it's coming from the left of 0, what is in common with all your x's? What do we think? If they're coming from the left of 0, because they're never going to hit it, they're not hitting it, they're all negative, right? So all your x's are negative. So then you can go ahead. This is legit. Like, this is how you're going to kind of solve this. So because it's the left of 0, come on. Oh my gosh. What is going on? It keeps closing. It's a sign. Oh, maybe I'll like try. There we go. Okay, now I'm like nervous with this. Okay, so now you can simplify it and actually take the absolute value of it, which gets rid of the bars, like you're already like evaluating the x, so any negative is going to turn positive, which turns into, I don't know if you need this step, but we're just going to do it anyway. -1, which means your answer is -1. All right. Those are that one. There's always an absolute value on multiple choice, no calculator. I've always seen it. So I don't know if we really need to do, maybe we'll just do this first line. But this is like where you get the graph and you have to do left, right, see if it exists, if they match and whatnot. So this is a mistake. Make sure you put in -3 over here. That's supposed to be a negative. Okay, so again, you just have to focus on like, these are limits. All of these are limits, but then f of -3 is like the actual value. So for -3 from the left, you're focusing on, okay, here's -3. If you're going from the left, okay, you're approaching -1, okay. And then here, if you're going from -3 from the right, okay, you're approaching -1. So then when you do the actual limit, because they both match, it's going to be the same answer. Okay, so both sides match. But then the function value, so this is like the actual value of it, is like this order pair. So that's a positive one. So that's what makes it a little different. And then we'll talk about continuity later. Hey. I don't think we need to do the rest of those. Okay, squeeze theorem. This is the picture of it. So essentially, like if you do the limit of that one, you get 0 times sine of undefined. So it's like, what the heck do I do with that? So you could try to algebraically mess with it, but it's like got a polynomial and a sine. Oh, the 1 over x with a sine or cosine is usually an indicator of squeeze, especially when it's got polynomial junk with it. So when you can't like do some like simplifying algebraically, this is usually squeeze. So what you have to do is take like a part of the function and figure out the range that you know. So like, I know that sounds kind of weird, but what I know is like normal sine, because there's just like a 1 in front of it, there's no numbers. The amplitude of it is between -1 and 1. Okay, so I know for the sine function, the amplitude is between -1 and 1. So that's your first step. If it was cosine, this would be the exact same first step. On multiple choice, they'll do an example where there's no bars. It won't be less than or equal to, it'll just be less than. That's wrong. So they'll try to mess with you with that. So now what you're doing is just kind of messing with both sides to try to make it look like this like original limit. So like I'm going to multiply everything by x squared. Okay, so I'm going to multiply everything by x squared because the goal is to make it look like the limit above it. Okay, so I'm doing a lot of steps here, but I'm going to multiply both sides by x squared, and then I'm going to add in the limit because now it fully matches. I'm going to just do this so I don't have to keep switching. So it matches what we had at the top. So we had -x squared less than or equal to, and then we had the original, the OG, and then we have x squared. And then what happens is you evaluate like the ends. And because you're plugging in 0, you get 0 less than or equal to 0. And you're like, okay, it has to be between 0 and 0. They're legit the same. So it forces the middle one to be equal to 0 as well. So you would say, therefore, by squeeze theorem, the limit x approaches 0, x squared sine 1 over x. And you guys are already trained to like grid out all the writing, so that's good, hopefully. So any questions on that? No. Okay, and then the last thing, these ones are really short. I'll skip 8. We don't need to do 8. Okay, this one is a special case kind. So these are for composite functions. The key for composites, you're not doing limits all the time. Like, I don't think this one's as intuitive to me. Because like, when you have a limit of a composite function, I would always just think you would do the limit of the inside, then the limit of the outside, but that's not right. So you're just like legit plugging it into the outside function. So you're only doing a limit once. Okay, so you're taking the limit of the inside guy and just straight up plugging in. But what you have to make sure you're doing is that you're not messing up the fact that f has to be continuous when you're plugging it in. So like this piece, so like whatever number you get after you do the limit, you can't have it be like a jump or like an open dot. Do you know what I'm saying? With the graph. So it's got to be like a legit like answer. It's got to be there. There can't be jumps and all that junk going on. Okay. So for number 9, okay, if we're doing, so we're skipping to this here. If you're finding this limit, it's essentially you're taking h and then figuring out the limit as x approaches -1 of g. So you're not doing 2 limits. You're only doing like the one. Okay. So in order for this to work, you're going to take the limit of x approaches -1 of g. Okay, so if you look at g, where's that one? This guy? So here's g. If you go to -1, notice g doesn't have to be continuous, okay? It's only on the outside guy that would mess it up. So if you plug that in, you would get 3, right? So -1 left and right, it would equal 3. And then this one works because if you look at h, the whole function's continuous. There's no like jumps and open dots. It's not differentiable. Spoiler alert, but like it's always continuous. So you can go ahead and be like, what's h of 3? And you'd be like, oh, it's 1. And then you could be done. So that one's like an A-B type question usually is on there, but then multiple choice will throw something like this at you. Okay, so for 10, they're going to ask you to find f of -1 minus x squared. So it's kind of like a sneaky composite because it's not like called g, but like that inside guy is a function. It's not like a straight up number. So the way you would start this one, like at first anyway, is you would take f and then you would have to take the limit as x approaches 0 of 1 minus x squared. So this is like your g. Do you know what I'm saying? So sometimes they put in like straight equation, right? So then you would do, go through the motions here. So you would do like for the equation, you could just straight up plug in, which is nice. You don't have to look at a graph. So if you plug in 0, you get f of 1, right? Plug 0 in for x, so 1 minus 0. But then if you look at the graph of f, it's like sad. Do you see what I'm saying? Like if you look at f of 1 on here, it's not continuous at 1. Okay? So it's not continuous. So you have to do this at like a different way. Okay? So how does that work? Okay? So this is the plan. Okay? The whole goal is to take the limit as x approaches 0. Okay? Well, the graph of f, okay, because this is f, right? The whole graph's weirdo one. Around 0, it looks like this graph, right? Because the goal is to do it at, why is this being crazy? I swear I'm trying not to touch it. Okay, here we go. So it's not going crazy at 0. It's only going crazy at 1. But that's okay because I want the limit at 0. All right? So the plan of what you're going to do is you're going to come up with an equation for f. Okay? So because I'm only focusing at 0, okay, so what I'm going to do is figure out what is f of x around x equals 0 because that's where my limit is. Okay? So if I look at it, my f of x around 0 only is a good old-fashioned right? Parabola, but it's up 2. So I can go ahead and be like, oh, it's x squared plus 2. Okay? Maybe I'll put that in red so I keep it consistent here. So what I'm going to do, if that's my f of x, I need to find the limit of f plugging in that thing. Okay? So the new strategy is I'm going to take the limit like I was doing earlier as x approaches 0, but I'm going to plug in that 1 minus x squared. So it's like I'm going to go, so it's like I'm here, maybe I'll write this too to make it more sense. So I'm going to go f of 1 minus x squared, right? I'm just plugging in like the equation I made for f, and I'm going to plug in this in for my x. So it's like I had to makeshift an equation for it. Okay. And then when I plug it in, okay, I plug in the 0 like old school style, I'll get my answer. So what is that? 1 squared plus 2. I guess I don't need that step, so 3. Okay. So if it's not continuous, what you're going to have to do is you're going to have to figure out like you have to come up with the equation for f. So